Alright, hello. So I'm actually recording this after I solve the problem that I have to do. Uh, Basically, this is pretty helpful to know, but it's not really something like you're gonna understand just by seeing it. So basically, the chain rule, which is really important in this problem that I'm gonna do, right, pretty much states the derivative of a function composed in another is the derivative of the first function times the derivative of the second function that's composed. Alright, so now that that's out of the way, we can get to solving. Hey everyone, today we're going to be evaluating the derivative of f of x equals e to the power of cosine of 2x. So I actually have my eraser selected, so let me not do that. Cool. So first step, well, actually, before we get to the first step, quick things to note here. So here we're going to actually have to use the chain rule twice. That's because we have our first function inside like of another function, which would just be like this exponential one right here, right? So that's like saying e to the x, and then x was replaced by something else, in this case cosine of 2x. And then our second function here that we're going to have to use a chain rule for is actually this cosine of 2x at the top here. Alright, so now that we've just stated that, just to make sure, we can begin. So first off, I want to use proper notation, So the first part of this in the chain rule, this will just stay the same. It just drops down and stays the same, because there's nothing we can really do to it. Okay? So now we have to multiply it by the derivative of cosine of 2x. Alright, so this is where the chain rule comes in a second time. So again, we're going to have to, first we're going to have to derive using the trig function. So in that case, this will just become, hold on, alright, so in that case, that'll just become negative sine of 2x, okay? And we just did that by taking the derivative of cosine, that just becomes negative sine, and the 2x just stays right there. We don't do anything to that section, because we don't need to, that's not what the rule calls for. Now, we're going to actually be taking the derivative of the second section here now, so we can see that if we just do. Alright, great. So, quick things to note, we're obviously going to have to use the power rule here. We can just take out the 2, that's fine. Of course it's still multiplying, it's like factoring it out. So we'll just end up with that right there, and then times everything else, of course. Whoops. So let me just do that off to the side here. So we know, right, we're trying to find the derivative of just plain old x. So this is kind of like saying x to the first power, right? Because anything to the first power is just itself. So basically, for the power rule, you're going to have to subtract this by 1, and then multiply it by its coefficient. So you'd end up getting 1 times x to the power of 1 minus 1. So that's 1 times x to the 0th, or just 1. So, of course, we have 2, and then the derivative of x, which we just figured out is 1. So 2 times 1 is 2. Alright, now let's get back over here. Alright, so not too much else to do. Yeah, just use proper notation again. E to the power of cosine of 2x, then times negative sine of 2x times 2. Alright, and then for our final part, we're pretty much just going to be combining everything. Let's choose another nice color here. Yeah, so we pretty much just combined everything, and that is the derivative. So f prime of x is equal to, let's just do negative 2e, and of course we just move this negative sign here, we move the 2 here, it's easier to read like that, you know, nothing crazy. So we have negative 2e to the power of cosine of 2x times the sine of 2x. Alright, so that's pretty good.